Hi, this is an idea presentation of a mobile computing project. We are from Group 2. The idea is to get a 3D model of tourist locations. For this, we use data from cameras and geotags and even photos taken by tourists at that particular spots. This is a cost effective way of visiting places. And you know that once a 3D view is made, it is available to everyone on the internet, and it can be kept updated as there are more images and more data of that particular place. Our solution of approach is to, as mentioned already earlier, is to just collect data from the surveillance cameras and even the data from users with their geotags on social media and the photos. From this, we try to create a 3D point cloud using this data and you know the geotags. Since combining data and creating a model is more of requires more computing power, we are trying to include the concept of volunteer computing, where devices that are interested can volunteer their processing power so they can get some data from the server and try to compute the 3D points of a particular image. The novelty of our idea is there are existing models that can create 3D point view like the Waymo we see on our roads, which have a revolving camera that captures 360 degrees on top of the car. But it couldn't be updated all the time and it's more expensive. So from our idea, we just collect data that is already existing and create these models. It's more economical since we are just trying to use the existing data. Coming to the mobile computing, so first starting with an application, we have a mobile application where users can select their most interested destination or location for a 3D view. So the most interested or opted location will be chosen, and the app also collects geographical information and depth of the objects from the pictures taken by the users. The data is then uploaded, and the most important part is processing, for which again we are using a technique from mobile computing called the volunteering computing to process these images. Moving to the related work for this particular project, we know Google has millions of users and millions of photos uploaded for different cities and locations. So the main three steps on a high level are recording the data or collecting the data. The second is processing the data, and the third will be publishing our results. In the related to the first step, which is recording the data, we have Google, which employs internally created data collection cars to collect data at various sites. So to determine the algorithm or their processing idea is to determine the positions of the streets using the vehicle's GPS and a few other sensors, navigation sensor, and even the wheel encoder. Related to processing data, we have models for creating post trajectory from an image. Further, they can also determine the depth and orientation of an image. Orientation, of particular objects in the image, and create a facade for these objects. Any objects like buildings and even the street. So this can be developed. We already have models for this. Later, coming to the publishing the results, there is Google that tiles up the photographs based on various zoom settings and stitches it into panoramas. The team, of course, privacy is an important aspect. Any person or a license plate or any private information in an image will be blurred out. Hi, coming to the novelty of the problem, building 3D viewpoints using this technique of high definition requires a high definition cameras. Build like we know Waymos that create street views. This is very expensive and it's a time consuming process. And the output of this way of implementation can be outdated because there is no chance of updating it now and then. So with our method, we could have most recent data, so we could have most recent models. And yeah, though it's a bit less accuracy, it is more updated than any other models. Coming to why our solution is novel, we are building 3D models based on data that is already existing. Like even the Google images or the surveillance cameras that are actually in that location. And we don't actually do this 3D points for all locations. It's just only to the places of interest. So it avoids a lot of unnecessary data collection, right? And it is also, like mentioned before, it's like it focuses on utilizing existing resources, which also includes the pictures taken by customers in that even the use any person traveling through that location per se. Coming to the solution for our project, the first thing is deploying a mobile application, where we users can vote for their most preferred place to get a 3D point. Then we collect you the we collect a we do a feasibility study on that particular location to check whether the place has devices or data sources that are required for our algorithm. There is a Google Maps and an API that accepts a parameter called prominence. This way we can make sure we get enough pictures from the users to actually build a good 3D view. Further, the various factors like sensors present on each device, sensors like depth sensor, compass, speedometer, they play a key role in building these 3D views. By converting the coordinate system of the camera's sensor plane to the real world coordination system, we can determine a mathematical relation between the points in the 2D to the 3D plane. Since we receive many images that are duplicates of the same location, we can train the model and even do error correction or even test for our accuracy in this accuracy of our solution. Going further, we plan on using Berkeley Open Infrastructure for network computing, which allows integration of cross-platform devices and perform the task of merging the 3D structures. The architecture has nodes, so the processing can be split among the nodes. For example, results from one node can be shared immediately, and the next node or the volunteering node can start processing from that point. Coming to that is the solution part, and then coming to the feasibility of our solution. The most important part is the user, who can trust in us and share photos even the photos on Google, some private Google or private cloud, who are willing to contribute for this 3D model. And of course, we are assuming that there could be surveillance cameras on the locations. um, and different mobile devices have different camera parameters like focal length and pixel clarity. We need to update our system regularly with new device information and consider those parameters while building these 3D viewpoints. Further, a initiation is from the user who is requesting for a 3D point cloud for a particular location. So it could take some time to gain popularity. And new mobile devices with new features are always coming in the market. So we need to keep it updated in the program, in the project concept. And there is always a scope for new processing or computing methods which can speed up the whole process. Here are some references that we went through while uh, you know uh, researching about this project and different concepts and ideas. Thank you.